Hello everyone, welcome back. Let us continue our discussion. We are in week 7 and this is our second lecture. This week our topic is design of deep beam, and let us quickly go through the design steps that we earlier discussed. So for a deep beam, the L effective by D ratio should be less than 2 for simply supported and 2.5 for continuous beam, right? And for L effective, we know this clause to find out the effective length, span length from the minimum of these two center to center distance between the supports and 1.15 times the clear span. Next is the most important thing for deep beam. The strain profile is not linear as we have in case of shallow beam, right? So here you can see the strain profile of a deep beam, which is at the bottom. It starts with linear variation. Then this is the neutral axis, which is not as simple to look at as in case of a shallow beam by balancing C and T. But here we have the empirical expressions given by code, which is Z equal to 0.2 L effective plus 2D if the L effective by D ratio is between 1 to 2. Otherwise, it is 0.6 L effective if it is less than 1. For continuous beam, it is 0.2 times L effective plus 1.5 D if the ratio is between 1 to 2.5, right? Otherwise, it is 0.5 L effective. So that gives us the lever arm, and the moment we get the lever arm, we can estimate the steel. And for that, we have these additional requirements. So we can go for curtailment, but for curtailment, we have to make sure that this condition is satisfied, which we discussed in the previous class. And in case of negative reinforcement, actually we have to go for different zones, right? So we have a first zone which is 0.2 times D from the top, and there is a second zone which is on the either side of the mid depth, and mid depth is 0.8 D from the top. So we have identified these two zones, and then we have to provide the reinforcement accordingly. And for that we have vertical reinforcement, just like stirrups, and we have side face reinforcement for this deep beam as per these two clauses, okay? And then of course the minimum thickness to avoid buckling, okay? So these are the more or less guidelines that we have already discussed, and we have solved an example case for a continuous beam. Now today let us solve a simply supported deep beam and see what are the different provisions and how we can evaluate the amount of steel required. So now we have a simply supported beam. Grade of concrete is M30 and grade of steel is Fe415. Width of the beam you can see 250 millimeter. Then overall depth, the complete depth is 3.75 meter. Clear span, this is 6 meter. And the live load is given here 215 kilonewton per meter. Now our task is to design this beam. It is a simply supported beam, so you can expect it will have a maximum sagging moment at the middle. Okay. For that, let us first evaluate the effective span, L effective. It is minimum of these two. So we have L effective here 6.3 meter. Now L effective by D is 3.75 meter. So 6.3 meter by 3.75 meter, which is 1.68, which is less than 2. So as the supports are, it is simply supported. So we have a case of a deep beam. Next is what? Let us calculate total load. For that we have dead load. And for dead load, we have 25 kilonewton per meter cube as the density of the reinforced concrete. So we can find out the dead load, which is 23.44 kilonewton per meter. And we have live load, which is given 215 kilonewton per meter. So we know the total load acting. So the bending moment we can find out using these loads, and the bending moment is 1182.95 kilonewton meter. Now, for the simply supported beam, we can calculate now Z, which is 0.2 times L effective plus twice D. So if you calculate Z, it turns out to be 2.76 meter. Then we can find out actually the required area of steel, which is M by 0.87 FYZ. And this area of steel is 1.187.1 millimeter square. Now, we provide main reinforcement as 6 number of 16 millimeter diameter bars, and then the depth of this reinforcement from the bottom fiber we can also calculate. This is 622.5 millimeter. Okay. So we provide this reinforcement in this section. Okay. I will show you the detailing in a minute. Then we also have to provide vertical and horizontal reinforcement, which is 0.12 times the gross cross-sectional area, which is here, that is 300 millimeter square per meter length of the beam. So we provide 8 millimeter diameter bars at a spacing of 250 center to center on both faces, right? So you can see how we can evaluate the steel. Now, horizontal steel requirements are also there. That is the 0.2% of the gross cross-sectional area, which is 500 millimeter square per meter depth of the beam. So we provide 8 5 diameter bars at 250. Now comes the detailing part. So we have it here. So we have the bottom 5 bars. So 16 diameter bars, if you recall, we have provided in 2 layers, as you can see here, 3 in each layer. Then we have horizontal and vertical bars as marked here. So in both the directions, we have uniformly distributed 2 layers of 8.5 at the rate 250 center to center. And the zones are marked. Bottom zone for main reinforcement, it is 622.5 millimeter. And for the remaining part, the bars, horizontal bars, these bars are uniformly distributed at a center to center spacing of 250 millimeter. And these are the vertical reinforcement. So that shows the complete detailing. Now, if you go back, we have used unfactored moment here. So you can provide a factor of 1.5 because this is the unfactored UDL. So in that case, this moment will be 1.5, and then here the moment will be 1.5 times. So the steel will be AST times 1.5. So the steel required, main steel required, AST is equal to 1.5 times, we had 1187. So this is 1187. So the factored steel required is 1780. Now, if we provide, say, 16.5 bar, so we require 16.5 bar for this factored bending moment. We need 8.8. So we can provide 8.8. So provide 9 bars. Okay. So in that case, this detailing will improve. So we'll have actually 3 more bars at the middle. Spacing will remain same, so that will not be disturbed. So this is for the factored loading. Okay. So this example clearly shows you how to design a simply supported deep beam with the given information and what are the different steels that you need to provide for the complete detailing. Okay. So just practice. If you have any doubt, do let us know through emails and we will clear your doubts. Thank you very much.